Hello engineers, welcome back to Engineering Design Simplified. If you want to learn more about how to analyze mechanisms using analytical method, please subscribe to my channel and press that bell button so that you will be notified when I upload a new video. In this video, I will discuss transmission angle for inline slider crank mechanism. In this picture shown is a typical inline slider crank mechanism. This link AB is crank and BC is coupler and this is slider. So offset between crank center and slider sliding plane is 0. So it is an inline slider crank mechanism. So the transmission angle is the angle between coupler link and vertical axis of the slider shown here. So gamma is the transmission angle. So let us see in the coming slides how to derive equation for this one. So from this picture, this link length is L2 and this angle is theta 2. This link length is L3 and this angle is gamma. So B prime, that is this height, can be written as L2 sin theta 2 equal to L3 cos gamma. So from this equation, gamma can be written as gamma equal to cos inverse L2 by L3 into sin theta 2. So this is the equation to find transmission angle of this inline slider crank mechanism for any given crank angle theta 2. So minimum transmission angle will occur when theta 2 is 90 degrees. So let us substitute theta 2 equal to 90 degrees in this equation. So we get gamma minimum, that is minimum transmission angle, equal to cos inverse L2 by L3. So this is the minimum transmission angle when theta 2 is 90 degrees. Similarly, maximum transmission angle will occur when theta 2 is 270 degrees. So let us substitute theta 2 equal to 270 degrees in this equation. We get gamma max, that is maximum transmission angle, equal to cos inverse minus L2 by L3. So this is the maximum transmission angle from this point to this point. Now let us solve a problem to find gamma minimum and gamma max. So in this problem we have taken crank length L2 equal to 30 millimeter, coupler length L3 equal to 70 millimeter, E offset equal to 0 millimeter, since it is an inline slider crank mechanism. So from previously derived equations we can find gamma minimum as 64.62 degrees. Similarly, gamma max is 115.38 degrees. Now let us take the same problem to find transmission angle for crank angles crank angle theta 2 from 0 to 360 degrees at an interval of 15 degrees. So in this column we have written theta 2 from 0 to 360 degrees at an interval of 15 degrees, and in this column we have calculated gamma, that is transmission angle. So in this problem also we have taken L2 is 30 millimeter, L3 is 70 millimeter. So the transmission angle is plotted in this graph here. So along horizontal it is crank angle theta 2 from 0 to 360 degrees. Along vertical axis we have plotted gamma, that is transmission angle. So this is the variation of transmission angle with respect to theta 2. That's all for today's video. If you like this content, please like, share and subscribe. Thanks for watching.